Hey everyone, thank you for joining us today. Today we're going to be chatting about Splunk Observability.
Joe, did we lose Dana?
It looks like we lost Dana. So I guess we're going to be talking about observability for AI. So we can kind of get it started, and I'm sure Dana will pop back. So I'm Joe DeBlack here, the product manager on the infrastructure monitoring team working on this. Let's go through, talk about.
Just to quickly introduce myself, my name is Dana Lord. I'm a principal product marketing manager here at Splunk, and I'm joined here by my awesome product experts. If you all want to introduce yourselves.
Well, I'll start. I'm Joe DeBlack here. I'm principal product manager working on infrastructure monitoring and observability for AI.
Hi everyone, I'm Kashyap. I'm a product leader focused on AI application security, and I've been working over 20 years to help customers deliver secure and seamless digital experiences. I'm super excited to talk to you about it today. Passing it to Bob.
Hey everyone, I'm Bob. I'm a product manager on the APM team, also working on observability for AI.
Awesome. Thanks, team. A quick recap of our agenda. We'll be walking through why observability is important now, what observability for AI is at Splunk. We'll do a deep dive into features. You'll see some demos along the way, and then we'll end on Q&A and next steps. Awesome. So let's get started. We know that digital resilience is being tested with AI. So AI systems have become more distributed, more autonomous, and embedded in critical operations. That's why folks like you are probably asking questions like, is my model trusted and operating efficiently? Traditional infrastructure has also transformed to include more layers and more complexity across cloud, data center, and edge environments in order to manage AI workloads and resource utilization. Applications have evolved also from simple and deterministic to complex and adaptive. And this rapidly evolving AI introduces unmanaged risks. Security risks such as sensitive information disclosure appear. You can see some examples, some real world examples that we've probably all heard and experienced. Other consequences of unmanaged AI risk include financial damage, litigation risk, reputational damage, compliance risk, and data leakage. These challenges can lead to irresponsible AI, poor customer experiences, and lost trust. Therefore, traditional observability is just not going to cut it. Observability has to evolve, and teams need observability that ensures AI apps and infrastructure have high performance and quality, not only to detect things like underutilization, hallucinations, bias, inaccuracies, unoptimized inference workloads, and more to reduce latency, errors, and other inefficiencies, but also to correlate business problems to new forms of telemetry across the AI infrastructure layers, including vector databases, orchestration frameworks, GPUs, LLMs, you name it. We need to also ensure AI apps and infrastructure have high security and reliability in order to detect prompt failures and injection, toxicity, and more to reduce risks like liability, scrutiny, and reputational damage. And so that is what we mean by agentic observability. It's having best-in-class observability tools for the AI era. At Splunk, this includes everything from application infrastructure and digital experience monitoring to correlated business insights, app security, observability for AI, and now with Cisco network observability. And there's also the Splunk platform to analyze a ton of machine data. There are three critical components to agentic observability. The first is fixing and preventing with AI agents. And these AI agents can instrument, detect, troubleshoot, and even remediate issues faster before spiraling out of control and before users ever notice. That frees teams from toil and reactive war rooms and allows you all to focus on solving really complex, novel problems. Second is observing AI agents and infrastructure because AI needs oversight, especially given its complexity and non deterministic behavior. And third, unifying observability and showing business impact for end to end visibility that connects user experiences and business performance so that you all know to act where it matters at a cost aligned to value. So today, we're focusing specifically on the ability to observe AI agents and infrastructure. This is also known as observability for AI. So if we're talking about observability for AI, this is what we mean. I'm going to turn it over to Kashyap to speak to the foundation of observability for AI.
Thanks, Dana. So what do we mean by security? One of the key foundational pillars we believe we want all of you to achieve is to deliver responsible AI. And a key ingredient of delivering the responsible AI is to help secure the AI. And as a part of Splunk Observability, we are making sure that that is one of the key foundational pillars of delivering observability for AI. What do we mean by security? We want to ensure that if there are any risks in the category of privacy, the category of security or safety, all of those are delivered in context to you as a part of your observability solutions of Splunk. And this includes security risks such as prompt injections, PII leakage, tool poisoning, and many, many more. And you get visibility right without having a swivel chair experience between your observability and security solutions. As all of us know that the AI landscape evolves and changes every day, there's something new coming together. Along the way, the threat landscape is becoming quite significant also because AI underneath and fundamentally has a model that works on top of executing both instruction and data together. So that makes it inherently insecure. From a community perspective, the community has come together to land on these top 10 AI threats. These have the ones that the OWASP community has highlighted, including the top three. By no surprise, include prompt injection, leakage of sensitive information, and supply chain threats. As many of you have heard, and as Dina mentioned at the start, some of these have already had an impact out there, including the ones from what you saw from where it can even be an embarrassing outcome for the organization, or it can also be having a financial impact in terms of how these threats can manifest. One of the biggest ones that has the most wide scope is the prompt injection one. And we want to give you a quick preview that even if you are considering your models that are using a cloud provider-based solution for the AI, there is a risk element to it. In this case, let's take a quick demo of this. Here, what we are going to show is the Google's Gemini model. Now, it's very widely, been out there, delivers a lot of value, but with it, it's also something where, for example, in this demo over here, you see where we are asking the model to give us some, very risky information about creating a bomb over here. Obviously, that Google Gemini comes back and says it will not cover that. But with a simple prompt injection, you can see that it came back and showed all the instructions how to create one. Now, again, as we discussed, AI is evolving very quickly. The model providers are going to continue to enhance their capabilities. But as a vendor and as a community, we want to work together to deliver a layered defense model that helps you achieve your responsible AI outcomes together with the model providers so that you can achieve that better together story using the observability and model providers security solution. Along with it, we also want to tell you that the world is evolving from a regulatory point of view. One of the examples over here is the AI EU Act that came into being in 2024. It has already started being rolled out, with February 2025 being the first deadline, and a further higher rollout is planned in August of 2026. What this will mean is that all companies that roll out AI-based systems need to undergo regular audits of their AI systems throughout their life cycle. They need to assess the performance, predictability, interpretability, safety, and cybersecurity compliance, and implement guardrails against generating harmful and misleading content. So what this means is we want to ensure that as you roll out your AI across, whether it's in the EU region or across the globe, you are adhering to the local regulatory standards, and all of them are coming together around the same core tenets of protecting and delivering an auditability of the AI itself. So at this point, we want to take some feedback from all of you. Here is a quick poll. We have to get some feedback from you. As we talked about, there are several cybersecurity risks that are showing up in the AI space. We want to get a poll from you in terms of which of these AI risks that you see are most critical to your organization. The poll will be available for 30 seconds. So please take a few seconds to provide your input to us. We have 5 options over here. The first option is it the sensitive data PII leakage that you're most concerned about? Are you concerned about the prompt injection? Or is it toxicity, misinformation, or any other security risk that you have top of your mind? I see some inputs are already coming in. That's great. Thank you for keep them going. We have a few more seconds to provide your inputs. I see almost half the audience has already responded, so please provide your input if not yet had a chance. Awesome. So keep that going for a few more seconds. Which of the security risks are you most concerned about in your organization? All right. Counting down to the last 5 seconds. 3, 2, 1. Let's take a quick look at the results over here. Over here, we see that it's a pretty important outcome. What you're telling us is you are very focused on privacy-related issues. PII leakage is very important, followed very closely by both prompt injections and misinformation. And toxicity is a lower focus right now. So thank you for giving that input. We definitely are covering these as a part of our solution. And we want to tell you more about it very shortly. With that, I'll pass it to Bob to cover the next half. Go ahead, Bob.
Great. Thanks, Kashyap. Let's talk a little bit more about what we're actually building within observability for AI. So if we think about the 3 pillars that we're building currently, one is really into visibility into the infrastructure stack that's actually backing your AI application environment. Secondly, you really want to look into what is actually going on in terms of interactions and calls, your LLM calls within your applications, and understanding what is actually happening within each individual LLM call. And thirdly, you want to have a view of what is actually going on with your agentic applications, right? Understand for these autonomous agents, what's actually happening, how well are they performing, and other performance metrics. And underlying all of that is security, which Kashyap has talked a little bit about. We'll talk a little bit more about in a few slides. Great. So when we think about AI agentic monitoring, it really expands the scope of problems that typical application teams are now in charge of, right? Traditionally, when we think about observability and APM, the problems are really focused around application availability, right? Tracking down errors and latencies, and that's a huge problem in itself. right? We have a number of tools within Splunk Observability to address that. Tracing tools, being able to get insights into your services, your alerts, your dashboards. Those are all built for that. But with the AI application sort of boom, right? We have a lot more issues that could come up. You could have dissatisfied customers who are upset with the results of your AI applications. That opens up legal liabilities as well. As Kashyap mentioned, there are things where a customer might say like, hey, like I bought this Chevy Tahoe for $1. Your AI agent sold it to me. Is that legally binding? Is that something that your organization really wants to try to address? So as a result, we're building things like quality scores and evaluations of how your agents are actually handling these interactions, as well as giving you visibility into your individual agents, as well as your conversation level details. Secondly, as Kashyap mentioned, there are security issues driven by things like privacy leakage. That's why we have things like security evaluations and integrations with Cisco AI Defense. Thirdly, cost is always in the background, but cost is a bigger issue here because you have to sort of monitor what the consumption of your applications are actually running, right? So are you using about the right amount of tokens, or are your costs spinning out of control? And lastly, there are risks to the fact that you have a new infrastructure stack, right? There's specific AI components that you now have to integrate into your overall environment. So that's why we have infrastructure monitoring specific for AI components now as well. Great. So we'll talk specifically around AI agent monitoring and what this entails. So what we're building is essentially a way for you to visualize, firstly, your AI agents. How are they performing? Who they're talking to, right? Are they talking to tools? Are they talking to vector databases? What is the actual underlying workflow that's happening right now in your application environment? You'll also be able to understand individual interactions, right? So being able to see, what interactions generated errors, what interactions generated issues surrounding, bias or hallucinations, being able to get that visibility so that you can go in and flag issues and also address any problems that might be arising within your applications. Great. And so in terms of, how do we actually monitor your AI agents? If we think about the traditional world of APM, most metrics are primarily focused around requests, errors, latency, and duration. Those are sort of the golden metrics that we've looked at in the past. With the introduction of AI agents, there's a number of more metrics that teams need to track. Examples of this would include things like quality metrics. As I mentioned earlier, there are things like, is my agent producing toxic language? Is it giving responses with bias? Is it actually giving relevant responses? Is it hallucinating? Those are all important things that we need to track. Alongside security metrics, as Kashyap mentioned, things like, are you leaking PII? Are there attacks on your agents, right? Is someone trying to do a prompt injection attack? And then finally, as I mentioned earlier, cost and token usage, right? Are you using about the right amount of tokens for what you expect? Or are the costs associated with your AI application spiraling out of control? And you would need to start figuring out how do you mitigate that? Is everything performing as expected? Or are you going to face a budget issue because you spent way too much on your tokens? So I'll just talk a little bit about the key capabilities we're building out. Firstly, we're building an agent-centric view, so allowing you to sort of get visibility into each discrete sort of autonomous agent, what is actually happening within that agent, what other agents is it calling, what tools is it calling, understanding a little bit about whether the agent is producing biased responses or hallucinations. We'll be able to aggregate that data so that you can generate alerts on that agent, figure out, is my agent underperforming or is it performing as we expect? Secondly is really that conversation-centric UX. So being able to see the actual interactions that happen, right? The inputs and the outputs, understanding, what actually happened, what did the user say, what was passed along the chain to, to downstream agents, and being able to see, how did that overall conversation propagate through all of your different agents, through your different tools, and be able to also correlate that with your underlying microservices, right? Because a lot of these are still built on top of your actual application environment. Thirdly, semantic equality evaluation, right? So that's around understanding, given the inputs and outputs, what were the actual issues that arose, right? Is everything going as expected, or are you generating hallucinations? Are you generating biased responses? We'll have built-in quality evaluations to help you track those. We'll also be supporting things like custom evaluations where, if there's a specific evaluation or quality metric that you want to track within your organization that's important to your team, you would be able to generate those as well. And on top of that, being able to provide, alerting on top of that so that you can see, so that you're notified, hey, like your agent is suddenly producing a lot of hallucinated data. This is something that your team needs to address immediately. Otherwise, as I mentioned earlier, you open yourself up to legal liabilities or potentially a very angry end user base. And then be able to correlate that right with things like agents. Are your agents overall producing biased responses, or are they performing as expected? And then lastly is integrated security risks. I'll talk a little bit about this, but Cash App will go into a little bit more on the following slide. But basically, this is around having built-in evaluations for things like prompt injections, data leakage, and being able to see where are those security hotspots across your AI application environment. And with that, I'll pass it back over to Cash App to talk about security.
Cool. So thanks, Bob. So as we were just talking about, as a part of the solution, we want to give you in-context visibility across your spans and traces that shows you not only the AI performance information, but also security information that covers the categories of privacy leakage, which you told us is very important. And right inside this view, you can see that we have identified a personally identifiable information that is part of that specific span and trace and highlighted it. Similarly, we will also be providing the capability to identify prompt injections, command execution, and in the future, other solutions and threats such as toad poisoning and custom threats also. All of this is mapped to your span trace AI agents that are running inside and the LLM models. And you can decide to either deploy this using API-based integration or through a proxy-based integration delivered as a solution from the Cisco's AI Defense integration. So when you invest inside the Splunk Observability and Cisco, you are actually taking the value out of the entire organization to be able to come together to deliver this outcome and deliver a secure and responsible AI. So with that, it's time for one more demo. Let's show you this entire solution end-to-end with what Bob presented and the security and the outcome of what agentic AI looks like.
AI apps are powerful, but risky. Quality can slip, costs can spike, and security issues can hide in plain sight. That's why we've invested in extending Splunk Observability to agentic applications. I'm an SRE currently on a call for a new agentic application that offers flash sales to draw in customers. I've just received an alert that something is wrong with the application. I start out looking at the AI agent monitoring page, which gives me a bird's eye view of the behavior of the application and each agent. Splunk captures core information about the agents as well as evaluation scores for quality metrics such as relevance, coherence, and accuracy. It looks like the campaign generator agent is unhealthy and its factual accuracy has started dropping. I then click on View Conversations for the agent to investigate further. This takes me to a filtered view of the conversations for this agent. From this visualization, I'm able to quickly identify low quality and high cost interactions. Since Splunk Observability is integrated with Cisco AI Defense, I know we're both detecting and protecting against security, safety, and privacy risks. From here, I can drill down a conversation to understand exactly what has happened. This view includes the user input, the output generated, as well as agent workflow, tool calls, and steps taken to generate this response. I can clearly see the campaign generator was flagged for low factual accuracy and is claiming we have glow-in-the-dark t-shirts. The tool call to validate the accuracy of its ad message failed, so it has been hallucinating information about our t-shirts. From the AI insight, it looked like the system prompt has recently been updated, which must have affected how we call this particular tool. Because we have clear visibility into quality, cost, and security for our AI AI-driven apps, we can switch back to the previous version of the system prompt and get our sales back on track.
So with that demo, we want to get more input and feedback from you. Here is one more poll question. What are your greatest concerns regarding deploying of agentic LLM-based applications? And we have 4 different options here. Please share your feedback in the poll. Are the concerns for security, for quality, for performance, or any other areas that you need help with to deploy agentic-based applications? We'll again have the poll open for 30 seconds. I already see that many of you have started providing your responses. Please keep going. Again, the question is, what is your greatest concern for deploying agentic or even any LLM AI-based applications? We have about 5 seconds more. Very good feedback and attendance submissions coming in. Thank you for that. All right. 3, 2, 1. Awesome. Let's take a look at your feedback over here. Okay. So the top concern that you are sharing with us is security, followed by performance and quality. So thank you for sharing that feedback. And again, since we are on the poll, we have one other poll also that we need your feedback on. So I'm going to shift to that next one. Please keep your feedback going. This is super helpful and great feedback. So the next question is, which teams are in your organizations are responsible for monitoring and deploying AI agentic based applications? Is it the observability team? That can be the IT ops or engineering. Second option, is it a new team or a new center of excellence team that has been set up to roll out these applications? Is it the AI team or is it some other team? So once again, the question is, which team in your organizations are responsible for monitoring and deploying AI applications? Is it the observability team that includes IT ops, engineering, DevOps? Is it a new team that has been created to roll out these new AI applications? Is it the existing AI team or is it some other team? All right, we are about 20 seconds in. We have 10 more seconds. Please give your responses. So counting down 5, 4, 3, 2, any more responses? Keep them coming. All right, we'll close the poll and share the feedback over here. All right, so based on the feedback, it looks like, wow, 50% have shared that this is the observability IT ops engineering team. Equally, then the second category is some other team. And the rest is between the AI teams and the center of excellence. So thank you again. With that, I'll pass it to Bob to share a lot more value that we're delivering on infrastructure monitoring. Bob.
Actually, it's Joe. I'm going to be jumping in there on infrastructure monitoring. So,
Joe.
Yeah, happy to join in. So, we want to talk to you about infrastructure monitoring in AI, right? And so when we say infrastructure monitoring in Splunk Observability, we mean monitoring the physical infrastructure, the software platform infrastructure, and the components that are all building blocks of your applications. And so as you're composing, applications and agents and all of these components, you're using these technologies as foundations to build upon. So it could be as simple as, we're using cloud services or we're using GPUs to execute our models, right? But this capability is really important because it allows you to monitor each of these little things. So you are able to monitor the resource utilization, critical, identify where the bottlenecks would be in those components, and to monitor the usage and use that information for troubleshooting of applications. So let's talk about kind of like the major layers of what you're typically doing in monitoring AI applications. So in generative AI applications, generally you have a model that's behind it somewhere. So this model is provided either cloud-hosted model, so it could be like GCP or AWS, and they have a bunch of foundation models, and these are very typically used because these, basic, GPT kind of large language models are really good at language, right? And so you might be augmenting that with some models of your own. And if you're using models of your own, you're either deploying them in the cloud in Kubernetes, or you're running them on premise in your own infrastructure, also likely on Kubernetes. Typically, these are deployed as microservices applications. And there's a set of model serving platforms. So things like Ray or NVIDIA AI Enterprise or Run AI capabilities that allow you to go and deploy models and use the set of GPUs you have available and essentially dispense those out to your various teams. Because all of this is running in a Kubernetes cluster generally, you can have visibility also within the context of that cluster of what's going on, and gives you very detailed information about, like the underlying GPU usage, what you have in terms of bottlenecks, power usage, IO, that it's used. And all of that's very easy to correlate to the specific node. So you can see if you have imbalances amongst your nodes. It's also correlated to things like named workspace and pods. So you can see what teams are using these, as well as what applications are attached to those models and services that are using those models in the capability, right? And so generally, this relies on the NVIDIA Data Center GPU Manager as the source of data, and augments all of that information into the Kubernetes visualization experience. Now, once you've got past basic models or model serving, that's the ability to run models. Now you have the models themselves, right? And so you can see model performance in two ways. One is you get models in package models, they'll deploy and they'll present a certain set of information to you. Things like time to first token and time per output token and latency and the number of requests processed, the number of requests queued, all of that kind of information will be available. And that information is coming from the packaging of the model, right? The model is running on GPUs, but it's packaged and managed as a microservice in Kubernetes. And that microservice is going to expose all of these internal details that give you an idea of where are the bottlenecks in your model serving. And they'll also tell you things like, if you're approaching your performance limit, they'll tell you like, would you be advantaged by having more memory allocated or more nodes allocated or something like that, right? So they give you a lot of visibility into how to improve things when you're troubleshooting. On the other side of model performance, we can measure the model performance by the way it's invoked and used. So within my LLM calls that my agent is making, it's making a call out to an LLM, it's getting a response, and I can track the requests latency, the token usage, and the errors associated to each one of those individual calls. And if I aggregate all that together, I have a view of the externally visible performance of that model. Now, these views are very closely correlated by common metadata, but you have to remember that there may be more than one service that's calling your model, and their model may be, or your service may be calling more than one model. So it's not a one-to-one relationship between the two. It's a many-to-many kind of thing. And that's why having both of those views is important, and also the ability to correlate the information. So when you get to troubleshooting and you can track through, oh, this is the service that's using, and this particular model is slow, that helps you identify all of that information. Finally, if we start looking at usage, and this is a very common usage pattern for customers is to look not only at the performance of it, but the costs associated to some of these models and figure out where all of that cost should be allocated or where the requests are coming from. So whether I'm using a cloud inferencing pattern, I'm using my own inferencing, or if I'm using some other technologies, I can get visibility into the allocation of all of that token usage and cost. And so all of that information is collected by the platforms, and then depends on what platform you're talking to, how I'm going to be able to slice that data. So I can almost always slice that data by the service that's associated to it, or the LLM or the service that's calling the LLM, right? I can also usually see things like project or AWS region or tag information that I put in a cloud provider portal. All of that information is collected on top of that base metadata, so that I can slice that cost information. And we have other customers that are using Light LLM as a means to do this. And I thought this was a really innovative kind of solution. And we built a set of built-in dashboards to allow people to see what the usage is associated to it. So Light LLM operates as a proxy, and then all of their services call through that proxy to talk to various cloud providers. So it allows them to switch models around between locally run or cloud sourced and move models from one cloud to another cloud or one region to another region fairly transparently to balance their usage. It also allows them to track, what team used this, what API key did they use, or what model or what service is making the call to that. And so that allows them, it gives them a lot of metadata attributes on the token usage to be able to slice that data up. And so that's kind of, what we can do from infrastructure monitoring. And this allows you to monitor all of the component technologies. So we didn't talk about like vector databases, other technologies that exist there, but all of the layers of technology, we have these kind of similar built-in views for. All right. So with that, I think that takes us to our next poll question. And I think we wanted to get some visibility into here of, for you, what are the critical technologies, or what technologies are your company using to be able to go and monitor what's going on with your generative AI applications, right? And so we've got a set of things here, the cloud provider things, frameworks like LangChain, LangGraph, OpenAI, the NVIDIA AI framework, NVIDIA GPUs, model serving platforms, vector databases like Weaviate or Milvus or Pinecone. And this is a rapidly evolving set of technologies out there, as most of you know. And so I'm sure if we came back and looked at these responses 6 months from now, we might get a whole bunch of new technology on there. But we're just trying to take a temperature on where people are today in terms of their technology base that they're monitoring from. All right, so we'll give, maybe 10 more seconds, let people click through this. Seem we're kind of getting to a pretty fair percentage of our users or attendees have been able to submit responses. Maybe 5 more seconds. 3, 2, 1. Thank you, all of you, for your feedback there. All right, and we'll see hey, wow, this is a very Azure OpenAI centric audience. That's interesting. And NVIDIA GPUs and inferencing. All right, so very good information and feedback. All right, thank you. And with that, so we're going to kind of wrap it up. We talked about what's available today in terms of our capabilities on infrastructure monitoring, agent monitoring. We talked a lot about security and what's available in that area as well. And with that, I think we're going to wrap this up and head to questions and answers. And so I will pass this back to Dana to moderate questions.
Yes, thank you so much, Joe. Thank you, everyone, for your engagement. Really great insights here. And thank you so much, Bob, Kashyap, Joe, for presenting. So it's now time for Q&A. If you have any questions that you'd like to ask us, this is the time. So please utilize the chat box to ask us any questions. If you have any questions about Splunk or observability for AI capabilities, let us know. To start it off, we do have some kind of pre-made seed questions. So for the team, to start off the Q&A session, when will observability for AI be generally available?
So I'll jump in. It's the observability for AI. The first bit of that is generally available today, and we have some new capabilities coming up in the next couple of weeks. You should watch the Splunk Observability What's New in our forums, because we've got some new exciting capabilities that we'll be rolling out before Thanksgiving.
Thanks. So just for some further context, so AI infrastructure monitoring, you can use that today. Go to our docs. We'll speak more about resources at the end. And then AI agent monitoring the alpha will be released, I believe, in a few weeks or in a week. So you all can dive in, utilize that. And then for our on-prem customers, we do have App Dynamics as well as Splunk App Dynamics. They do have LLM AI agent monitoring capabilities, and that is GA and so generally available.
And I'll also add that the security solution that we talked about will be available in February next year. So around that time.
Great. You all feel free to ask questions. This is the time. Again, don't be shy. The product team is here to answer any and all questions that you have. It doesn't look like we have any thus far, so we'll go ahead and continue with some of the other questions that we have kind of created here. What might make someone a great candidate for AI infrastructure monitoring or AI agent monitoring?
Yeah, so I think a good indicator is if you're already running AI applications or have AI infrastructure, whether you're starting out or you're more mature on that end. Either way, if you're trying to get more visibility, especially if you're facing the same problems that we mentioned on this call, right? If you're starting to ask those questions around, beyond just performance, but just also things like cost or security or quality of your responses, and you don't have any visibility to that yet, this is I think a prime candidate for something that could help you get those insights, right? So so I think the broad answer is, if you're dabbling in this space or if you're already an expert in this space, I think either way, I think it's great to look into what we can offer, because I think we do provide a lot of visibility in this area.
Absolutely. And also being able to correlate that to your other melt data, your logs, your traces, having it in one single view, connecting that to business metrics. This is really the solution to help you do that. All right, a final question. Since it doesn't look like we have any questions from the audience, if I'm someone that has Cisco, if I'm a Cisco customer, can I use observability for AI to monitor my Cisco AI pods?
Yeah, I can take that one. So absolutely. So Cisco, if you're familiar with Cisco's AI pod solution, or if you're not, it is a packaged hardware solution for training and inferencing. So it's a all-in-one solution using UCS hardware, Nexus switches, a storage provider, and a number of GPUs coming from NVIDIA, basically in a pre-configured package. And so that hardware package is kind of the easy button for on-prem inferencing and training. And Splunk Observability is optimized for that solution. So we've built pre-built views around all of the technology in the Cisco AI, as well as the technology that's that's coming from other that you're building into the AI pod to run your application. So all those component technologies are going in there, right? And so you can basically deploy the AI pod, configure your observability, and be up and running and inferencing in a matter of very, very little time.
Awesome. Thanks, Joe. Looks like we do have some questions from the audience here. One of them, so will the AI assistant for SBL be integrated into search without having to download externally from the Splunk base? Or maybe they meant the Splunk database. Unsure if you all know the answer to that.
I don't know the answer to that. I don't think any of us are in that team that's doing the AI assistant. So we'd have to reach out to them.
Yeah, Jane, it looks like, yeah, we'll get back to the person who had this question. And then finally, in what version is this? I think someone said, in what version is this ready to use? Or like, when
so
will it be available? Yeah.
Yeah, it's available now, and it's Splunk Observability. And so that's in the current version of that offering. We just release continuously in our SaaS environment, so we don't have like Splunk version numbers for that.
Yeah, I think we do require that you use the latest version of the instrumentation libraries in order to be compatible with what we're releasing here on the application side.
Yeah, definitely check the release notes on that, and then in the instructions on what versions of instrumentation and receivers. And that's something that, like as mentioned, this technology is evolving very, very rapidly in this space, and so we're with every biweekly release, we're adding support for new platforms and technologies and frameworks. So it's going to be something to always be aware of there.
Great. And then one last question before we wrap up here. Someone asked, once a threat is detected in Splunk AI, does the platform have a response for it?
Yes, the answer to that is yes. We, as a solution, will be having the capability to block those threats also. So that is one very important good point that you've also highlighted it, that you can actually put in place a blocking policy to block a privacy leakage or a prompt injection through the integration with Cisco AI Defense, so that any future such threats are averted in your AI application.
Great. Thank you, Kashyap. I think we have maybe time for two more. Someone asked, what's the pricing model if I already have App Dynamics?
Well, I think you need to talk to your account rep and see what the details were to turn it on. But I believe if you're an App Dynamics customer, you should already have these capabilities within the App Dynamics offering itself. So definitely reach out to the technical team on what you need to get started with LLM monitoring in App Dynamics.
Absolutely. And then finally, for AI infrastructure monitoring, how is that enabled?
Yeah, so the infrastructure monitoring components, all of that content is available, all the dashboards and navigator views and everything is available to all customers. It will appear in your environment when you start sending data in. So if you go and look at the documentation, search in the documentation and deploy the OpenTelemetry collector to go and collect information from your GPUs or any of these component technologies that you're collecting it from. Once we see that data pattern coming in, those dashboards and navigator views and everything will all just light up in your environment.
Awesome. Thanks, Joe. All right, so we're going to wrap up the Q&A. Feel free to reach out to any one of us if you have any other questions. But to end the call, we always share resources here so that you all can learn more and get started. As I mentioned before, AI agent monitoring will be in alpha. The preview is available today on our Splunk VOC page. So please sign up, provide the team here with feedback, and get started in getting hands-on with that product there. We also have an observability for AI blog where we deep dive into these capabilities. You'll see some screenshots of the user experience, get to learn more of like some of the things that we shared today. So please go ahead, read that blog. And then finally, as Joe mentioned, we do have documentation available for observability for AI to help you get started, learn more. So check that out. And yeah, get started. And finally, thank you all for joining. We really, really appreciated chatting and speaking with you all, answering your questions about observability for AI. We hope you have a great morning, afternoon, evening, wherever you all are.
Thank you.
Thanks, everybody.